In this lesson, we are going to continue to look at objects that have cutouts, basically plates that have pieces missing. Now, I added this page of notes because in the past I've had students sometimes have difficulty solving the problem like this, where you don't want to do that full subtraction method. If you're given a full plate made up of unit masses, like we have here, what you want to do is go back to a point particle approach. So go back to thinking of each box that makes up this 8 by 8 plate as being made up of a 2 meter by 2 meter box with 1 kilogram. Again, we want to keep everything in kind of a unit form. And I'm going to set 0, 0 down here at the bottom left. And then I'm just going to calculate the center of mass of the system. So this we know how to do. For point particles, it's m1 x1 plus m2 x2 plus m3 x3 plus m4 x4. Now, in terms of m1 x1, notice at x1 we have 1, 2, 3, 4 masses, and that's where the 4 here comes from. At x equals 3, we have 1, 2, 3. That's where the 3 comes from, and so on. So we get the center of mass in the x direction is 4. And we do the same thing now in the y direction. So in the y direction, we have, at y1, we have 2 masses. So that's why we have the 2 here. And then so on. We continue at y3, y5, y7. We simply now count the masses that we have at each point and do it as a point particle calculation. So you can see that when we do that, we get a center of mass position of 4 and 4.43. So we're a little above the center for 4. So again, for a multiple choice question, if it were a full plate, nature's balance point, it would balance at the center, 4, 4. Since we have the cutouts down here, so this section is missing, it's going to move up a little bit to this 4.43. So in terms of multiple choice questions, if they give you other points that are way off, hopefully you will remember these examples that we did. So again, very short lesson here. What I would like you to do is do the same thing for this box. So what you are going to do is assign point particle values. So you can use 1 kilogram for each of the unit boxes. Use a half kilogram for this one, a half kilogram for this one, half kilogram, and then 1, 1, 1, and 1. Set up the same coordinate system. Go through the calculation on your own and see that you get the correct center of mass position in a relatively short amount of time for this calculation. So I'm going to pause the video here, let you make the calculation, and then we'll unpause the video and take a look at the solution. So pause it now. Okay, let's take a look at the solution. So for this configuration, in the x direction, we have positions 1, 3, 5, and 7. So we have 1, 3, 5, and 7, and we're just going to count the masses at 1. So we have 2 full boxes, 2 half boxes, so we have 3 total masses sitting at position 1. And we just continue along in this fashion. Now in the y direction, we have position 1. Here we have to be a little careful. We have position 2.5. So that's why we have the 2.5 down here. And then we have position 5.5, 5.5. And we have position 7. So take a moment. You can pause the video here as well and take a look at the solution to see that you get the correct answer at 4 and 4.5. And again, even if it's a multiple choice question and you're unsure of which of the answers they're giving you is correct, you can very quickly point particle up this type of an object and make a quick calculation.